got this sequence of ACT prep videos that I've been trying to put together during the COVID-19 coronavirus outbreak for my students. I'm still hopeful that some of them will get a chance to take the ACT another time this year. Of course, it's been delayed. It'll be late spring or even over the summer, but you know, we're all just doing the best we can. We had 10 questions left on the math test, and it's the end of the test. So really, in actuality, you would be looking at most of these and just guessing. And when you're randomly guessing on the ACT, just bubble the same position all the way through. If you can't look at it and eliminate an answer or two, then just guess the same choice for every question. Theoretically get a couple right that way, and that's all you're really looking to do. But we're going to look at them together and see what sort of insights I can offer. But overall, my advice about the last 10 or so questions is that's really to sort out where exactly you're going to be in the 30s if you're a student that's going to score extremely well. They're really digging in and looking at not only are you good at Algebra 2, but like what parts of maybe pre-calculus do you know. So don't get overly stressed about these last 10 questions, but we are going to look at them together for completeness. Magic hat time. '51. The list of numbers 41, 35, 30, x, and y, 15 has a median of 25. The mode of the list of numbers is 15. To the nearest whole number, what is the mean of the list? So there are 1, 2, 3, 4, 5, 6 numbers. We know 4 of the 6 numbers, but we don't know all of them. The mode of the list of numbers is 15. So that 15 is also the smallest number in the list. Since it's the mode, that means that x or y1, we'll just assume it's x, has to also be 15. The median of this list of numbers would actually be an average of these two numbers. So whatever these two numbers are, they have to average 25. So I'm just going to assume that y is somewhere in here and write down the larger numbers from the list at the end. So 41 is the largest number in the list. 35, 30, and then if y were here, what number would you have to average with 30 to get 25? 20. So I don't know that that's exactly right for y, but it's something I can try that matches all of the stipulations. It uses all the numbers I was given. It uses an extra copy of 15 because the mode of the list of numbers was 15. And I chose to use 20 for y in this position because 1, it would be in the right order, and 2, it sets up my median of 25 like it was supposed to. The idea is that by doing this, I don't know that these numbers are right, but they're at least going to add up to the right amount, I hope, and then that'll let me decide about the average. So if I add these up, 15 and 15 is 30, 30 and 20 is 50, 50 and 30 is 80, 80, might actually have to start keeping track, and 35 and 41 is 6, no carry, 8, 12, 15, 156. 6 would go into that evenly. Well, 20 would be 120. So it's 20 something. Just going to go ahead and make a note of 20, subtract off the 120. That would leave 36. It would go into that 6 times. 6 times 6 is 36. So it's 26. So I'm going to go with choice C and just hope that I'm right. 52. You're given the following system of equations. Y equals x squared, rx plus sy equals t, where r, s, and t are integers. For which of the following will there be more than one xy solution with real number coordinates for the system? So I'm going to take the two facts I was given and I'm going to trade out, what makes sense to me is to trade out this y for x squared. And I'm going to rearrange the order. Sx squared plus rx minus t equals 0. And this now looks like a quadratic problem. And if you know the quadratic formula for ax squared plus bx plus c equals 0, you know that one of the things that really matters a lot with the quadratic formula, which the ACT does consider quadratic formula fair game to have memorized, is that what you care about is inside the square root b squared minus 4ac. Well, in my problem, b is r, a is s, and c is negative t. So I'm going to put this together using s, r, and t. So b squared would be r squared minus 4 times s times negative t. Well, negative times a negative is positive, so it'd be r squared plus 4st. I want r squared plus 4st to be greater than 0, which is choice F. So you can already see that that problem was just super tricky. They know what they're doing with all these variables. They're just hoping to confuse you. And again, every question on the ACT is worth 1 point. So it doesn't matter whether it's 52 or number 2. So if you can do number 2 in a minute and a half, and you would have to stare at 52 for 5 minutes to even stand a chance, do number 2 and a bunch of other problems. 53. The third and fourth terms of an arithmetic sequence are 13 and 18 respectively. What is the 50th term of the sequence? So there's a little bit of vocabulary here that maybe you don't know because you usually don't see it till Algebra 2 or Pre-Calculus. An arithmetic sequence is just a sequence of numbers where you add or subtract each time. So we're going to add or subtract each time. Always the same number though, once you get the pattern. They don't tell us the first or second number, but they tell us that the third is 13 and the fourth is 18. So I know that I'm adding 5 each time. They want the 50th term. They don't just want the first term or the second term or the next term. They're really sticking it to us. I'm going to actually go backwards 5 to get that the term before this was 8, and then backwards 5 again to get that the term before that is 3. And I'm going to kind of think of it as being like y equals mx plus b. Kind of, sort of. I know that I'm changing by 5 each time, and if I start at a first term of 3, then I would need to go up by 5 49 times to get to the 50th term. So if I do 5 times 49, that'd be the number of times that I add on 5. And then I started at 3, so I'll add 3 to that. 5 times 40 is 200. 5 times 9 is 45. So it's 245 plus 3. I'm hoping that 248 is offered as a choice. And that is choice A. And so I'm going to pick that and move on with my life. 54. One of the following graphs in the standard xy coordinate plane is the graph of y equals sine squared x plus cosine squared x over the domain negative pi over 2 less than or equal to x less than or equal to pi over 2, which one? Oh, they're trying to scare you with so many things on this problem. One, you may not know enough trig to do this problem. So a couple things that I want to talk about just that are helpful. Sine squared of x, you already know that, sort of. It's just that it's a common shorthand to write it instead of in parentheses with the square, to write the square on the trig function. So if we take what we know about right triangles, I'm going to label the angle right here. I'll make this A, this B, this C. Then what are some things we know? Well, we know Pythagorean Theorem. And I bring that up because it has squares in it, just like this did. That's why I think I might care about Pythagorean Theorem. And then you might know SOH, CAH, TOA. So sine of this angle would be opposite over hypotenuse, which would be B over C. And cosine would be adjacent over hypotenuse, which would be A over C. I did go through that trig a little bit fast because I'm assuming that you've looked at it on one of the other problems with me before now. So again, it's just that idea of opposite, adjacent, hypotenuse relative to this angle inside of a right triangle. Well, if we look at sine of x squared plus cosine of x squared, what you'll see is that sine is B over C and cosine is A over C. And when you square these fractions, you just are squaring both parts. And if you think about it, this looks an awful lot like that, but they divided through by C squared. So if you take this and you divide through by C squared, it would be the same as this, but in the other order. But wait a minute, C squared divided by C squared is equal to 1. So really this thing up at the very top is equal to 1. One of the things that you'll find if you take enough math classes is that you always learn more and more complicated ways to write 1. And sometimes 0, but especially 1. And so if this thing would always equal 1, that's actually choice H, because it's the only one that's constantly at some y coordinate that's staying the same. And so that's why I would choose H for that one and move on with my life. But again, it was pretty complicated trig that you've maybe not seen before. And if you have seen it before, there's a chance that you just automatically know that sine squared plus cosine squared is 1 as soon as you see it. Because when you take a trig class, that's called the Pythagorean identity. And so really this question is more than anything a test of who knows that by heart from trig. If they do, we're giving them a point on their ACT. Because when you get into the 30s, basically every question you get right is another point, or thereabouts. So this is really sorting out, like this last 5 or 6 questions are legitimately making the difference between who gets a 30 and who gets a 32 and who gets a 35 and who gets a perfect 36. Some years you don't actually have to get all 60 questions right on the ACT in math to get a 36 in math, but most years you do. 55 is another complicated trig question that you likely have not seen unless you're in pre-calculus. What is the period of the function f of x equals cosecant of 4x? Well, first thing, cosecant is the reciprocal of sine. And sine looks like this. So if you take a standalone trig class or pre-calculus, you learn that the period of sine is 2 pi, which is why these answer choices have a lot of pi's in them. But think about this problem. This end of the period here is usually at 2 pi, but you've multiplied it by 4, so it gets there 4 times as fast. So you would divide this by 4, and this would reduce out to pi over 2, which if this is 2 pi, this is pi divided by 2, this is 3 pi divided by 2. What we're saying is that it used to take all the way from 0 to 2 pi to run a full cycle of a sine curve. This one's going to run, because of the 4 there, making it run 4 times as fast, it's going to run a full cycle in the time that it takes to go to pi over 2. So it compresses the wave and makes it run much faster. And that's why I'm choosing E. Now the graph of cosecant does not look just like the graph of sine, but because it's related to sine, it would have the same period. 56. At the school carnival, Mike will play a game in which he will toss a penny, a nickel, and a dime at the same time. He will be awarded 3 points for each coin that lands head face up. So he's tossing 3 different coins, and he gets 3 points per head. Let the random variable x represent the total number of points awarded on any number of tosses of the coin. What is the expected value of x? So on the first flip, half the time he'll get 3 points. On the second flip, half the time he'll get 3 points. And on the third flip, again, half the time he'll get 3 points. If they made the points different for each coin, I would have to change these 3's based on what the points were for each of the coins. If it was a trick coin where it wasn't a 50% chance of heads, I would need different percentages. So really I'm just doing the percentage or probability times the score. And in this case, it's always that on average, they're going to get 1.5 points per flip for a total of 4.5 points. That's the expected value, which is a hard probability question. You might not know what this phrase expected value even means. Oh, and they wrote it as a fraction just for an extra kicker. It's h, it's 9/2. 57. I used to call these undefined term problems rather. They would use a word in the problem and then make a note or another sentence that would define one of the words from the previous sentence. And you might know this word if you've had enough advanced math, but they're just choosing to throw it in. For what positive real value of k, if any, is the determinant of the matrix k4 3k equal to k? So like if you've not done matrix math at all in like Algebra 2 or Pre-Cal, you have no clue what's going on, but they at least give you a shot. And they tell you in this note, the determinant of matrix ABCD equals AD minus BC. So if you look at this, what it ends up happening, if you look carefully, is that you multiply these together, A times D, and you subtract these multiplied together, BC. So we're looking for k squared minus 12, and we want that to equal k. We would subtract the k over and get it equal to 0. These are not like terms, don't combine them. And then now it's a factoring question. K minus 4 times k plus 3 would multiply to negative 12, but add to negative 1. So there I factored it. What would make this 0 is 4. What would make this 0 is negative 3. But they don't offer any negatives, so I want 4, which is choice B. If you had enough time and understood the problem, you could just start trying these and seeing which one ends up working. But I also wanted to show it as a factoring problem, so I did not work it by guessing and checking. Remember that when you work with guessing and checking, although this would be a hard one to do it for, start in the middle with the 4. I would ignore the bottom and the D at first, and I would start at the 4. and I would try 4, and if 4 doesn't quite get it equal to 0, but it was close, I know that it's probably 3. If it's nowhere close, then it's probably 12, and use that last guess to inform the next guess. Given a positive integer n such that I to the n equals 1, which of the following statements about n must be true? And then you look at them, and it looks like it's about when n is divided before the remainder is 0. They tell you that I squared is -1, so they're giving you a hint. It's an Algebra 2 pre-calculus question. I squared is -1. Well, then what's I squared times I squared? Well, I squared times I squared would be -1 times -1, which would be the positive 1. So if I to the n is equal to positive 1, this was a total of 4. So the first time this would work is when it was 4, and then it wouldn't work again for a little while. And so it needs to be things that are evenly divisible by 4. So it's F, that when you divide n by 4, the remainder is 0. It goes in evenly. If I were your Algebra 2 teacher and we were looking at this, we would talk about that you have the real number line, but also there's this imaginary number line. And we denote those numbers as imaginary with i's, and the powers of I actually cycle through these 4 options. So I to the first is 1, I to the second is -1, I to the third is -I to the fourth is back to +1. And it just keeps repeating forever. It's actually what this question's getting at. Do you either know that or can you figure it out in a hurry? 59. For -pi/2 less than or equal to theta less than or equal to pi/2, absolute value of sine of theta greater than or equal to 1 is true for all and only the values of theta in which of the following sets. And then they write them in a very complicated set notation kind of way. So this is the second problem on this particular version of the ACT that actually requires you to have beyond basic knowledge of the trig functions. We just got done talking about how sine looked like a wave a minute ago in a previous problem. This is +1. This is -1. This is 2 pi, pi, and 0. So sine is 0 at 0, pi, and 2 pi, and then it rises and falls in a wave in between. It's at 1 at pi/2 in between those, and it's at -1 at 3 pi/2 in between those. But because of the absolute value portion, it would equal 1 at both pi/2, and the -1 would get flipped due to the absolute value. And it actually, normal sine never gets higher than 1 or lower than -1. So we don't even care about the greater than part. That's just to mess with people. And that matches, oh wait, they were mean and they backed it up and they said, but wait, we're not going to give you from 0 to 2 pi. We're going to give you from -pi/2 to +pi/2. So if you can visualize the wave at -pi/2, it would be down here. Backing up the wave, it would be down here. And so we actually don't want this one. We want the -pi/2. -pi/2 and pi/2 is choice A. Last question apparently is going to get its own piece of paper. 60. Ray PK bisects angle LPM. I would go ahead and just start there. Angle LPM. There's my angle. I don't know what it looks like. When I draw an arbitrary angle that I don't know what it looks like, I tend to default to something in the vicinity of 60 degrees-ish because it's a decent sized angle. It's easy to look at. Ray PK bisects, so it cuts it in half. So I don't know what this is, but it's the same. The measure of LPM, so this whole thing, LPM is 11x. The measure of LPK, so just this part, okay, we're not going to get to call it x. We're going to call it 4x plus 18. What is the measure of KPM? This is actually probably the easiest one of these last 10. They're hoping you're just so exhausted you don't see that. You could double this and it would equal 11x. And you distribute the 2 and it would be 8x plus 2 times 18 is 36 is 11x. Subtract off the 11x. You would get left with 3x, 503. X has got to be 12. I got all kinds of room, so I'm going to use it. Now they wanted KPM. They wanted this. And that's just another copy of the 4x plus 18. So now I got to take 4 and multiply it by 12 and add 18. That's 48 plus 18. It's going to end in a 6. So I'm leaning towards K is 66. I would carry 1. All right, well, that is going to be it. Let's take the magic mirror back off. You managed to make it through all of those math questions with me. Good job persevering. Don't stress about how many from the last 20 or so, the last 2 videos you think you might even be able to do. Just remember the strategy of if you're trying to get what's considered like a benchmark score, which is around an average score, a 19, 20, 21, 22, you're trying to get half or a little more than half of the questions right. So don't treat it like 60 questions in 60 minutes. Take some of the stress off. Tell yourself that you're going to go into that test and you're going to spend the first 50 minutes doing a really good job on the first 40 or so. And then if you have to guess on the ones you're not sure about, that's okay because you weren't sure about them anyway. And if you have to guess on the ones that were from the last 10, 15, 20 questions, that's okay because a lot of those were going to be hard ones for you anyway. I am going to do not full videos, but just you're going to get to watch a math teacher work the parts of the other 3 tests. I do have some amount of advice to give on those in some future videos, but I'm not going to look up the answers beforehand, and so there'll be some questions where I'm going to mark it and say, I hope it's that, and I'm not even going to bother to go check it because during the actual ACT, I wouldn't be able to check it, and I wouldn't be stressed about it. I would just mark an answer and move on. So that's going to be it for now for this one, you guys and gals, and I hope you're safe and healthy and happy at home as best as you can be.